In this series of videos, I'm going to be talking about the mcuboot bootloader. mcuboot is a community-driven project seeking to implement a secure bootloader for microcontrollers. You can read more about this project at its website at mcuboot.com. Before getting into details about mcuboot itself, though, let's cover some background so it will be easier to understand where mcuboot is used and what problems it is trying to solve. The name mcuboot is composed of two parts, MCU and boot. The name is pretty descriptive, and these two terms make for a good starting point to describe what mcuboot is. So let's start with MCU. A quick Google search shows that this stands for the Marvel Cinematic Universe. Although there is a trend for reboots in comics these days, sadly the MCU in mcuboot doesn't really have anything to do with the Marvel Cinematic Universe. Our use of MCU instead stands for the more mundane microcontroller unit. The Wikipedia page on microcontroller has some good background on the history of the term, and importantly, what it tends to mean today. A microcontroller is a small computer on a single integrated circuit. In modern terminology, it is similar to, but less sophisticated than, a system on a chip, SoC. If you think of the design of a typical PC, the computer itself is divided into multiple discrete components. The CPU is usually a chip or module itself. The motherboard usually has numerous chips on it, implementing various functionality. The system memory, usually DRAM, is on a separate component, and storage, either disk or SSD, is also separate. In contrast, a microcontroller, all or at least most of the necessary components to make the system are generally found on a single chip. Because of the desire to embed these devices into other things, microcontrollers usually have significantly less RAM, storage, and processing power. For example, whereas a desktop machine may have many gigabytes of RAM, probably terabytes of persistent storage, and might run at multiple gigahertz, a contemporary MCU may have a few hundred kilobytes of RAM, maybe a megabyte of flash for storage, and run at dozens or hundreds of megahertz. These constraints all create severe limitations on how these devices are programmed and used. Sacrificing all of this does come with a significant benefit. The microcontroller is now a single chip that can be designed into another product, usually only adding a few dollars to the cost of the device and not dwarfing the board space or power consumption. These kinds of computers open the Internet of Things world to many things that wouldn't otherwise really be able to have computers in them. What does this mean concerning mcuboot then? The small memory and slow processing speed have a significant impact on how the bootloader is designed. There are a lot of problems that we will have to solve differently than we would on a more typical general-purpose processor.